I think we'll start right at the very beginning. Start right with the battery as the electrical unit. A battery does not store electricity. This is important because it works different in your testing than it does if you were working with something like an air tank that stores air. The battery has to make electricity, and it has to make it as fast as it can, and it will make it according to demand and try to keep up with the demand. The greater the demand, the faster the little gremlins in there have to work. Another thing to remember, that electrons flow from negative to positive outside of the battery through some type of a resistor. This is called the electron flow. However, there's a lot of companies that now follow the old conventional flow when you trace electricity. But keep that in mind, because when you get into these trucks with diodes, you have to know which way the electricity is going through the diodes. Keep in mind that electrons do flow from negative to positive, but if you know that the company wiring schematics are following a conventional flow, like follow the conventional flow, just like the electrons were flowing that way, because that's the way they set it up. And they'll throw you, it's thrown me, they'll throw you if you don't watch that. Okay, first of all, a battery has the capability of producing a tremendous amount of electricity if it's a good battery. The amount of electricity that is capable of producing depends upon its size. Actually, it's this amount of plates, surface, that comes in contact with the electrolyte. If a battery has one positive and one negative plate, that's not going to produce very much electricity. But if it has a lot of plates, it will produce more electricity, not more voltage. Voltage that it produces depends upon two things. One, the cell's material. In other words, what that battery is constructed of. The lead acid battery produces 2.1 volts per cell. The nickel cad battery produces 1.2 volts per cell. The zinc carbon cell produces 1.5. A lemon with a piece of lead stuck in it and a nail in the other end will produce some amount of voltage. If you take that nail out and put a piece of copper in it, it will produce a different voltage. So the voltage depends upon the material that it's exposed to the acid. Keep in mind, this thing is not a battery. It is one cell. A battery means a bunch of things, two or more. Battery cannons, battery of oxygen tanks or acetylene tanks, a battery of cells. So each cell produces a certain amount of voltage, and those cells are connected in series. And if they are connected in series, then you add the voltages. Let's use the 2.1 volts, and each cell times 6 cells then would equal 12.6 volts. Generally, we just refer to it as 12 volts. If you connect the cells in series, or excuse me, in parallel, then no matter how many you put together, they will all still add up to 2.1. You don't add them like you do mathematically. When they're in parallel, you just keep the same voltage. In series, you add them. Now, cells are nothing more than what I just showed you, and a battery can have 6 or 4 or 3 cells in that battery. And if we have more than one battery connected to another battery, and if we connect these batteries together, this being the positive, this is the negative, that's in series, that is the same as if they were all encompassed in one case. It's still adding the voltages. So if we put two batteries together, each one being 12 volts, we'll have a total of how much?
20.
How much?
24.
Okay, if we put a 6 volt together and a 12 volt, how many volts will we have? 18 volts. Pretty simple mathematics. Okay? Now, because a battery can produce an awful lot of voltage, or excuse me, amperage, let's take one battery, and the symbol for a battery, by the way, is a sharp and a long, sharp and a long. Years ago, they used to put one cell, and that's what the sharp and the long refers to as a cell. They used to put 6 cells for 12 volts. That takes too long. They don't do that anymore. They just draw battery symbols and designate either 6 volts or 12 volts or 24 volts. You don't have to draw even amount of cells for the voltage that you want. But if we have a 12 volt battery, how does that battery know how much electricity to send out to the load? We can connect up a little light or a great big starter motor. How does it know how much electricity to send out? What controls the amount of electricity that goes out to that load? Any of you know?
Resistance.
Okay, the total resistance. And that's referred to as resistance total. The reason we say total resistance is because there can be more than one load on a battery. If we connect up the load in parallel, this is a parallel circuit. By definition, a parallel circuit says there is 2 or more resistors with 2 or more paths for that electricity to flow through. Electricity then can flow from the negative side up here. It can go through this resistor and back to the battery. It can also come up here through this resistor and back to the battery, and so on. Just as many as you put out there. There is a certain amount of resistance for this resistor, R1, a certain amount of resistance in R2, and a certain amount of resistance in R3. Those added together is the R total. Now, there's a special formula that if you have to find the resistance of a parallel circuit, you have to use the reciprocal formula. You don't just add them together. If they are in series, then you do add them together. And most of the time, you don't have to figure this out, but once in a while you do. So you have the reciprocal formula in your reference books, and you can figure that out. If they're added in series, and by definition, series means there is one path for 2 or more resistors. The electricity leaving the negative post has to go through resistor 1, then to resistor 2, 3, 4. Can't even count here. And in that case, the resistance is added together to get the RT, or resistance total. The greater the resistance, the less the current flow. Okay? Now, the easiest way to remember that is if you have a tank of water and put in 1/2 inch pipe that is 20 feet long, you'll get a certain amount of water out of that tank. And if we add another 20-foot length of pipe, we will get less water out of the tank per minute than we did with one pipe, because it's harder to flow through that pipe. For every pipe we add on, we have more resistance therefore less current flow or less water flow. Okay? If we add on more than one pipe in a parallel circuit, we will get a certain amount of water out of this half-inch pipe, the same amount out of this one, and the same amount out of this one, if those pipes are all half-inch pipes 20 feet long. In other words, if the resistance is the same in the circuit, like these are all 3 ohms, 3 ohms, and 3 ohms, each one of them will carry the same amount of current flow through that resistor. However, if this pipe is a 4-inch pipe, 20 feet long, naturally more water will come out of that 4-inch pipe. So if this resistor has less resistance, it only has 1 ohm of resistance, then more electricity will flow through R2 than it will through R1 and R3. That's in parallel. Let's see what happens if we put different size pipes in series. If we have a 4-inch pipe coming out of the tank, and that pipe is reduced to a half-inch pipe, the amount of water that will come through will be the same as if we had a half-inch pipe right here. Because plenty of water can get through the 4-inch pipe to the half-inch pipe, and literally then there is no restriction, no resistance as far as this circuit is concerned. All the water that can get through the half-inch pipe can get through the 4-inch pipe, no problem. So if we come over to a resistor, and this resistor has 0.5 ohms resistance, which is almost nothing. And this one has 6 ohms resistance. All the electricity that is needed to get through this resistor can very easily get through this one. And so there will be no basic resistance. The total resistance is still 6.5, but that 0.5 resistance compared to the 6 is almost nothing. Plenty of electricity can get through here, and because it can get through here, this light will not glow. It will not turn on. Or it may, in some cases, if these are just a little bit less, like maybe this is 3 ohms against 6 ohms, it still can get through here without any problem. And this light may turn on just a little bit. You may not hardly notice it. But this one will still be bright. If this comes closer to this one, of course, then this will turn on a little more and this one will be less bright. Now that's important to remember that in your test procedures, because a test light takes such a small amount of electricity. There are very few things that you connect it to that it will affect, that it will operate. Some relays that take a very small amount of electricity, if you connect the test light in series, that relay will function. Because the test light pulls enough electricity to make it work. However, if you use a voltmeter, and that's the symbol for a voltmeter, if you use a voltmeter in series with any component, it will not turn it on. It will not function. Because the voltmeter takes such a small amount of electricity that it will not make anything in that circuit function. You will always read battery voltage through the test line. In other words, it doesn't matter how many resistors we put in this line. If we put a voltmeter in series with that group of resistors, and this is a 12-volt battery, what will the voltmeter read? 12 volts. There will not not be a voltage drop in that circuit other than at the voltmeter. There is not a voltage drop in the circuit unless there's current flowing through the circuit. That's important to remember. And there is no current flowing through the circuit when it's open or when the voltmeter is connected in that circuit, because a voltmeter takes virtually no electricity. Such a small amount that we say it doesn't take anything. Now technically, keep in mind, technically the voltmeter has to take electricity. Otherwise it wouldn't function. But as far as your test procedures are concerned, it doesn't take any electricity to run it. It's like talking out both sides of your mouth, because you'd have to say it takes electricity, otherwise it wouldn't work. And that's one important test, because if this circuit is literally broken right here, and there's wires every place else connected, what will the voltmeter read? Even though it's connected to a wire right here, what? Zero. It will read 0 because there is no current there for it to operate on. Okay. So that tells you then whether the circuit is good or bad. If you connect the voltmeter into the circuit and it reads 0, you know there is a break in the circuit someplace. If you have any questions, don't be afraid to speak up. One of the biggest problems we're having in troubleshooting is understanding what voltmeters and ammeters do, and ohm meters. That's the reason that as far as testing, you need to know what the voltmeter and ohm meter does. An ammeter, how do we connect up an ammeter?
Series only. Series
Okay.
resistor.
What does that mean? Well, there's a resistor, and that is a complete circuit. That is referred to as a simple circuit. Simple circuit has just one resistor in it. To make a test with an ammeter, the circuit has to work. So if it doesn't work, there's no use putting the ammeter in it to even find out it doesn't work. Obviously, if it doesn't work, it's going to read 0. So the circuit has to work. This light has to be on to this resistor, whatever it is. Then, if it is working, then we can break that circuit and connect the ammeter into the circuit. We connect an ammeter in here, and this is the symbol for an ammeter. The positive side of the ammeter goes towards the positive side of the battery. The negative side of the ammeter goes towards the negative side of the battery. So the thing to always remember, where you won't get in trouble then, is to make the circuit work without the ammeter in it. Break the circuit. The light doesn't work. Connect up the ammeter, as shown here, so the light will now work again. As you follow that procedure, you won't blow the ammeter. The ammeter tells you how much current is flowing through the circuit, like water meters tell you how much water flows through a pipe. It doesn't tell you pressure, just how much is flowing. Now an ohm meter, see what we do with an ohm meter, so that going through some of these test circuits we'll understand what they're doing. An ohm meter is really a voltmeter. I'll draw this in pieces. There's a voltmeter. Down inside there's a whole bunch of electronic equipment, which consists of the brain part of this thing. And there's also a battery in there. In other words, it has its own power supply. what it's doing is sending the electricity through this gadgetry, through one side of the battery, out the wire to a voltmeter, from the voltmeter out to a lead, and from the other side of the battery to a lead. When you test a resistor, a light, or whatever, you actually connect up to this light and send electricity through this resistor. And because of this electronic equipment, it measures how much electricity goes through that resistor. It's actually taking a voltage drop across the resistor